What's up guys, this is the final stage of your practicing. This part 4 for quadratic functions and this math with Daniel Dallas. Here we're going to consider problem 3. This is exam style question, and here within the problem we consider different aspects of vertex form, of transformations, and in general sketching the graph and finding all different critical points and significant points in order to proper sketching and graphing. Okay, make sure you watch all the previous video. That was the previous problem 1. Here's is going to be the next one, so I split it in 2 parts. So make sure you watch this video with clear explanation how it works, how to find the vertex form from the standard, how to convert it back to standard form. And today we're going to consider a new problem 3. Pause the video, try to do by your own, and let's get started. So here's the game, and a boy hits the ball from the ground level. The flight of the ball can be modeled by parabola, so just remember projectile motion. If you're also going through GCSE physics, it's about motion in 2D. This is definitely projectile motion, and the path in ideal condition should look like a parabola. That's what the model tells you. The path of the ball has the following expression. So y equals negative 0.49x squared plus 1.732x. So where is the y? Is the height of the ball in meters. So that keywords, this is the height of the ball in meters above the ground level, and x is the horizontal distance in meters traveled by the ball. Okay, so horizontal distance. So that's why you have y from x, and this is parabola. Because you have negative coefficient a, definitely it's upside down, so generally you expect to have this sort of parabola. And in yx set. Okay, and we move next. We need to find the maximum height reached by the ball. So first of all, we need to define this point here, and also we need to define, let me see, horizontal distance traveled by the ball before it falls to the ground. All right, so let's get started. So maximum height is the maximum value for y. So that means we need to find y maximum. In other words, it's a vertex. So generally we need to define y vertex coordinate, and that will be the maximum. How are we gonna do? So the first way is to get using vertex form, but I'm not gonna do. I will use the formula. So x vertex is minus b over 2a. Just remember we did it, and let's calculate. So b is 1732 and over 2 times this small coefficient, and because minus and minus a will get the positive value. So 2 times 0.049. All right, let's use calculator because in this problem we have pretty weird coefficients, so that's why we need to use definitely calculator. It's definitely calculator based, or calculators allowed. And what I've got after calculating 17.7 meters to 2 decimal place. Okay, I just squeeze a little bit. So we've got maximum, it's not maximum height, but that's the maximum distance x. So that's horizontal distance traveled by the ball before it falls to the ground. It's not that, but it corresponds to the vertex point. All right, now how to find y? We just simply need to plug into this value instead of x, 17.7, and let's calculate how much is that. So we're taking this value and plugging instead of, so we've got 1732 times 17.7, and on top of that we subtract 0.049 times the value which is squared. So 17.7, which is squared. Okay, what I've got 15.3050. So if we round up to one decimal place, it's going to be 15.3 meters. And that's the maximum height. So actually on the graph, it's going to be the maximum height. What I'm going to do, I'm just going to put this value here, and that's going to be 15.3 meters at maximum height. So that's why y maximum is that value. Okay, next one, we need to find the horizontal distance traveled by the ball before it falls to the ground. Okay, because actually you can save your time. So normally what you should do saying that y equals 0, because the maximum distance is going to be when the ball reaches the ground level. It's right there. So actually this is the second point on y-x graph. It's here. So we equate to 0, y, because it's the ground level, in trying to solve quadratic equations. So simply we've got this. Plus 1732x equals to 0. However, if we go and say that we've got a vertex which is 17.7, and according to the graph, I just show you on the next picture, so on the next slide. So that's my actually graph, and what we found the maximum height, which is 15.3, so that's the maximum height. So what I'm going to do, I'm going to put this as the maximum height that we recently calculated. So 15.3 meters, and this is y max. However, we also found this point that corresponds to the x vertex, and the value, if we go back, we calculated that 17.7. So 17.7 meters. We can have a shortcut because this point is going to be twice more, right? Because we remember that x vertex point is simply arithmetic mean of x1 intercept and x2 intercept. So obviously x1 is 0 because it starts from the ground level. However, from here we understand that x2 is simply twice more than x vertex point. So we can say that x vertex is simply 2 times 17.7, and if we multiply by 2 we'll get 34, and so 35.4 meters. That's going to be x2. Okay, so that's why it's going to be the final height, sorry, the maximum distance traveled by the ball. Or you can go and solve this equation, so by factorizing. So you can factorize and say one value is x equals 0, and another one, if we factorize, we'll get this expression, which is factorized, times x equals to 0. So, and you equate each expression, each bracket, so one x is 0 and another x is also 0. Okay, so we calculate, you might calculate in two ways, and right now we need to work out the height of the ball when x is 10 meters and x is 8 meters. Let's get and do this part, but on the next slide. So we are on B right now, and what we need to do in order to calculate the height is simply we can use the graph. That's the first option. However, it's not precise, so it's better to plug those values instead of y. So that's why first we plug 10 and calculate y from 10. We just simply put 10 everywhere, and if you plug 10 instead of x and recalculate, so you'll get 1, so 1732, we multiply by 10, and subtract 100, multiply, because it's x squared, so 10 squared is 100, 1, 2 is going to be negative 4.9, okay? So we just simply transfer decimal point 2 times. And if we subtract, we've got the first value, that is 4.9, 1242 meters is going to be height when x horizontal distance is 10. Okay, in the same manner we can plug 18, but 18 we need to recalculate, not mentally, but using calculator. Okay, let's do that. 1732 times 18 and subtract 0049 times, you've got 18 squared, okay? 18 squared. And we'll have 15.3. So 15.3 meters. As you can see, so here we have at 10, we have those, oops, my bad. At 10, it means horizontally, we have the first height. Oh, sorry, let's use this color. From here to here, and this is around what we calculate, 1242. And when we take 18, so using the graph we can also do this. So 18 somewhere here, so 15.3. Wow, that's exactly around what we if we plug 17.7, so that's around, so 15.3 around. So that's the second height, 15.3. And the last problem here, find the horizontal distance of the ball from the initial position when the ball first reached the height of 30 meters. Okay, so we need to, in other words, we need to calculate when the ball first reached the height of 18 meters. So what I'm going to do, I'm going to one more time, so change another color. Let's take this one. So one more time, we have a parabola, just approximately like this. So that's the maximum point, but we need to calculate the horizontal distance when the ball first reached 30 meters. So 30 meters is somewhere here. And as you understand, this height can be reached twice when the ball first goes and rising projectile motion, right? And then falling. So that's why twice will reach the height of 30 meters. However, we need only the first one, and that's why we only arrange the first. So this is graphically, so that's graphically, that's 30 meters, and we need to calculate x distance when y equals to 30, okay? So what we're gonna do, we need to simply solve the quadratic equation. Now, how to do it practically without like drawing, I just show you in case you understand how it works, how the physics works in this case. So we plug in 13 here instead of y, because that's the height, so it means y value, and we equate to right side of our quadratic equation. So we've got definitely quadratic equation, and now we need to resolve it. So I transfer this part to left hand side, 0049 x squared, then minus 1732x, and at 13 we equate to 0. Okay, use the formula, quadratic formula, we can calculate the parameter, and here is going to be 1732 squared and minus 4 times 13 times 0049, okay, and over 2 times 0049, okay, that's times sign. So that's how quadratic formula works, and what we're going to do right now, just simply let's try to solve this. Okay, now go back to calculator. So 1732, then for example we take, let's check the minus sign first. I'm pretty sure that both values is going to be like, it's going to work, but we need to take the lowest value, so we take the minus sign. So minus sign is the nearest one, okay? I'm definitely sure. So let's take minus and square root of 1.732 squared and minus 4 times 13 times 0049. okay? And everything we divided by 2 times, so 2 times 0.49, okay? So what I've got 10.81 meters. If you use the plus sign, let's change for the plus sign. Definitely we get another value x2 greater. So that's why. So x2 is going to be 24.5 or 53. And we need to take the first value, right? Because that's the nearest one. So this is the nearest one, and that corresponds to the point when it first reached the height of 13. So that's why solution for C is going to be 10.81 meters. Okay, so it's done, guys. So I think I must say that congratulations that we finalized this course. I hope it was okay for you. I hope it was okay. So we figure out how to work with quadratic equations and quadratic functions, how to use complete and square, how to go through conversion, so converting from standard form into the vertex form and the way back. And also we understand how to plot this using data table and using just significant points. Hope you enjoyed that. Hope you like that. Hope that it was pretty clear for you. So share in the comments which crash course you would like to see in the nearest future. I tried to do my best because right now, after request for my majority of my students, I think I'll switch into A-level and consider some complicated questions that my students have. And also don't forget to check the Zealand's A-level class that I also recommend you to go through, and actually we'll be working together on the A-level. So guys, make sure you check it out and make sure you subscribe for both channels. So that was Daniel Dallas. Thank you guys. Peace out.